The objectivity involves a habit of mind and spirit, not the following of external procedures or rules. Put another way, the objectivity lies not in propositions, but in a disciplined disposition. Hello, everybody, and welcome to another episode of MindMatters. Today, for the first time, I'm your host, Lucien Koch, and with me in our virtual studio are Harrison Keeley, Adam Daniels, and Ilan Martin. Hello, everybody. So
Hello.
Today, we'll talk once again. Yeah, say hello, everybody. We got a slight delay here, but it's workable, I guess. So today, we're gonna talk again about this wonderful book, The Matter with Things by Iain McGilchrist. And since there are so many chapters in that book, we cannot talk about everything. So we picked chapters 10 to 12 for today, where McGilchrist talks about truth and truth in science in particular. As well as about the life sciences or this biology, basically, and everything, of course, from his hemisphere hypothesis, basically that the left hemisphere has a very different take on the world than the right hemisphere. So to just give a quick reminder, the left hemisphere is sort of our abstract representational organ, so to speak, and it sees the whole world as a representation and tends to break everything down into small particulars, and then takes these particulars and constructs all kinds of models with them, and basically treats everything as the same, as every object as a kind of class, or as something that is not unique, but like rather a member of a class. And so obviously it is important to have this kind of logical, like reality chopping kind of outlook, but it can also go spectacularly wrong. And therefore we need the right hemisphere, which tends to take a whole look at reality and is much more directly connected to reality and experiences the world more as a direct thing, and not so much as a representation and like atomistic kind of way. So with that framework, in these chapters, he asks the timeless question: what is truth? And in particular, what does that mean for science and how science goes about things? And also what that means for biology, which is, of course, also very important, because as we know, nowadays, many biologists tend to view man or humans as machines, and from that derive all kinds of theories about selfish genes and what have you, which can also be like a massive problem. Yeah, so does anybody want to jump right into it?
Sure. Oh, before I mention, though, right at the beginning of the show, I want to direct everyone to Luke's new Substack. What's the URL for the Substack, Luke?
Luke Talks, LUCTALKS, luketalks.substack.com.
Great. So you've got 3 posts up so far, or well, 4, probably 4 by the time this episode will go up, or maybe more by the time this goes up. And you talk about a lot of the things that we talk about on the show. So kind of like a really cool philosophical approach so far. And you've got a review of Dave Berlinski's book. What's it called again? Is it Human Nature?
Human Nature. Yeah.
Yeah. So we'll put the link in the description. I'll recommend that, and also mention we won't be talking about ponerology in this show, but I also started a ponerology Substack, so I'll put that in the show too. So all of our viewers and listeners can subscribe to our Substacks and read
Get awesome stuff.
Yes, get awesome stuff. But on the subject of this book, I want to read just a short little bit that stuck out to me from first from chapter 10. So this is dealing with the question, what is truth? And I read these chapters several months ago, so I had to kind of just skim over them and see which parts I'd highlighted to refresh my memory on what he says about all this stuff. And this one kind of stuck out. So he's talking about the different approaches to truth. Luke, you already introduced kind of the really basic summary of the hemispheres. So he relates approaches to truth to these hemispheres in this chapter. And so he writes, this is page 396, one of the hemispheric approaches, that of the left hemisphere, aims to close down on truth. The game lasts, while it does so, only because the longed-for close down has not yet happened. Once it has, the game is over. So you search for the truth, you find it, and you're done. But then he continues. That of the other, that of the right hemisphere, aims to open up to truth and sees the truth as a never-finished seeking after and evolving of something that is disclosed by the very process, which the game of life continues. So this more open-ended, journey or path to truth that never closes down. And he kind of relates this, to some examples, and he expands on it in this chapter. And also in the chapter on science, because he says that essentially science should be this kind of open-ended thing. It should never be set in stone because it is a process. And any truth, and for this statement, he quotes some philosophers and some scientists, like he quotes Whitehead, that any truth is always a partial truth and it's always a contextual truth. I think he quotes Whitehead as saying something like, this formula or this equation, that the truth, the scientific way to state things would be to say not that this statement or this formula is true in all cases, but these are the situations in which this formula is true, and not the situations in which it is not true. So that any scientific truth has to be encapsulated like that, and say these are the circumstances in which it is true. And on a more broad basis, from those two little bits I read, it is truth itself is for McGilchrist, from a right hemisphere perspective, this evolving thing, this evolving truth, because the context always changes and we're always learning new things, and so we can get closer to the truth. Now I think I'm representing him, more or less correctly, and slightly paraphrasing. We can approach the truth, and we can get a truer understanding of things, but it's not something that we can ever fully grasp, because we are always limited by, and not even necessarily limited by, but we are always in a certain context where certain things apply and other things won't apply. So it will any statement of truth that we make, if it is true, will be limited by that very fact. And there are some places we can go to when we get into science, but I just wanted to state that as kind of a starting point for how he looks at the nature of truth.
Well, I think one of the things that most impressed me, particularly in the chapter on science and truth, was this distinction that he draws out in different approaches to science between those who are more left hemisphere dominated versus those who might lean more into the right hemisphere approach to science. And one of these big distinctions, and he quotes Niels Bohr and Max Planck. So you have some giants in the scientific field who attribute the process of discovery to intuition, imagination, inspiration, impressions, things that are decidedly outside of the kind of logical, strictly causal sphere of science that we're so often trained to think of as the scientific method. So the right hemisphere, if you will, permits for a more kind of loose bound of inquiry, if you will, that isn't so regimented and isn't so tied to absolutes. So there is something about the inquiry that is that is by its nature subjective, where, as he describes it, left hemisphere dominated scientists are all about objectivity. So in describing the objective pursuit of scientific truth, they would also seek to rule out themselves as the observer, or anything that would influence what is observed or personal to their being. And there's this kind of cold mechanistic approach to their version of objectivity, I think, that he spells out and says is actually kind of impossible, because scientists do have assumptions, they do have perspectives, they do come at their inquiry from a particular model or metaphor, whether they acknowledge it to themselves or not. It's just part of how they approach their work.
It's what's interesting there is that they're like that view of science as this like objective, in that cold, objective, analytical thing. I think he makes the point in one of the quotations that he puts in there that view itself is a left hemisphere representation. It's not even what those scientists would actually do. I can't remember the quote itself, but it's something like, in their actual practice, there are no scientists that actually do that. And probably, there are probably some that do it to a better, to a greater degree than others. But all scientists, when they actually do science, they do all of this right hemisphere stuff that they may not even be aware of. It's kind of like this schema, or this image they have of themselves that is in itself like an abstraction that doesn't bear much reality to what they're actually doing. And so, like you said, the process of science, he goes into the scientific method, and like there's this myth of the scientific method. It's not actually what people think. It's not like it's this purely like AI machine that's going through possibilities and things like that. Because to come to a hypothesis, the process of coming to a hypothesis in the first place is this immensely creative process where it's based on the assumptions you have, the Gestalt view of the situation you have. You're looking at something, some collection of facts and evidence, and there's a process going on in your mind that says, well, what is the best explanation for this? And the hypothesis is in itself a part of that process where you're trying to come to a picture, come to an understanding of how this all makes sense. And then that's where the scientific method proper starts, where you find the evidence, you test it, you see if that actually works or not. But the hypothesis itself is like the creative act in the scientific method that's based on all those things, like impressions and values. It's like you have to be looking for something. You have to be valuing a certain type of goal, or of you have to have a value for a certain type of thing that you're after when you're engaging in this scientific process. It's not like just, oh, this is the way things are, and this is how they're going to be, and duck, 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 duck. It's more amorphous, and even the discoveries themselves can come, like in a dream or in a flash of insight.
That's an interesting part for his. If I, like you were saying, it's an immensely creative process, and it's not something that people generally put science into as a creative process. It's not thought about as a creative process, and yet one of the things you're doing, you're taking data and then you're trying to make sense of it. And how do you make sense of it? It doesn't spell itself out to you in like a plus or 1 + 2 = 3. It's not there. You have to come up with it. You have to generate it yourself, and the only way to do that is by free association, creative thinking, allowing your brain to kind of wander and meander. And it's not, this very strict thing, which, if it all was just a left hemisphere activity, we wouldn't really be getting very far, because without the free association and the creativity, there's nothing to give life to any kind of endeavor. But it's also interesting the play between the two hemispheres, how one needs the other. The free association needs the kind of regimented drilling down, while at the same time the drilling down left hemisphere, the very regimented left hemisphere, needs some kind of creativity to give it life. So it's just, it's really cool to have an example, if you will, of how the brain needs itself in this kind of a way that makes it all work.
And I just want to say, about the imagination thing, that's actually pretty well known, or should be well known. I mean, Karl Popper stretched it a lot in his book, where he kind of comes up with this idea of falsification and all of that. And he actually says that, the imagination plays a huge part. I mean, you first must come up with ideas. I mean, as you said, Adam, data, not only can it be interpreted in different ways, but, you must generate it in the first place. And to generate it, you must ask questions and come up with ideas and all of that. And I think Collingwood even made the point that in philosophy, you actually know, what your result is before you even start, writing down the argument. That's maybe an extreme example. It's not always like that in science, but in certain ways it is, right? I mean, you have an idea basically, and then you set out and drill into the details. Like, for example, you see like a ball rolling or whatever, and you observe, oh, it's kind of slowing down and it looks kind of regular, so there should be like maybe some kind of mathematical regularity, and and you have this idea, and then you design an experiment maybe and do all of that. But the scientific method, the famed method, I think it's pretty much a myth most of the time, and at best it's a complete idealization of how this process works. And I just want to mention another thing that came to my mind, and that is that there actually isn't, nobody has a definition of science. It doesn't exist, right? I mean, many people have tried, but you always run into all kinds of conundrums, when you try to define what science actually is. So at the end of the day, it's basically like truth seeking, or something very broad, but this could be everything, right? It could also be like doing deductions in everyday life and figuring out, where you left your key or something like that. I mean, so it's really impossible. And I think that's also something that the left hemisphere, kind of thinks that science is something like really well defined, when in fact it isn't. And you can say it's maybe like an institutional thing, but it doesn't really help. So I just want to mention that, because there's this in today's day and age, there's this huge admiration for science. I mean, it's kind of like a surrogate religion, and it's kind of good to remember that it's not even defined. I mean, nobody even know what it is, so to speak. And I really liked how McGilchrist broke that all down, and just want to read one quote about objectivity that I really liked. And he says, objectivity involves a habit of mind and spirit, not the following of external procedures or rules. Put another way, the objectivity lies not in propositions, but in a disciplined disposition. I really like that, because it's, it doesn't try to define like this scientific method, or like this is science, which is impossible anyway. but rather says it's like about the discipline of mind, so that you really want to find the truth and go about it, right? And not like maybe like in everyday life where it's, maybe only matters to a degree, but you really want to drill down and to. So I really like this formulation. And he also says, that's another thing that I think that's in the chapter about truth that I'd like to mention, because I really thought that's an interesting idea as well, that he says that truth actually has no compelling power. So it doesn't automatically, let's say, convince people, so, I mean, we all know that, how you try to convince someone of something that you believe is absolutely true, and it doesn't go anywhere. So we always assume that just because something might be true, it's automatically convincing. And I thought that's a really interesting idea that also changes maybe the way we see science, right? Because in science, that's also kind of the idea usually that truth just convinces automatically, but that's maybe not the case. And he says that it's more something like that we are kind of like actively drawn to truth. So it's not something like the evidence that pushes us to it, but something that we set out to. It's more like what he says is kind of disciplined mindset kind of thing, but something that comes from within, basically. So I thought that also really interesting.
Well, so a few moments ago, Luke, you mentioned, how much science has become something of a religion in Western civilization, how it's vaunted and valued. But really, I think what we're witnessing is how scientism, which he makes a distinction between science and scientism, which is kind of like the ideological version of science, where there is this determination for absolute answers, where, just as we've been saying for the past few moments, science as truthfully pursued is a process. It's not something that, you would imagine someone like Klaus Schwab saying, and this is the answer, and that's it. There is no finality. And that would seem to be the trap among many people who are seeking certainty, who it's kind of like the authoritarianism or the totalitarianism of science, where the inquiry is so limited and so bound by the conclusions that it seeks to prove in order to satisfy certain preconceived ideas about how things are, or preconceived ideas about where things should go or how things should be. That it is it's really a bastardization of the true pursuit of knowledge that one would hope a scientist is going to pursue. So that became it's very liberating to read his descriptions and to think, well, I'm not a scientist. I don't have the tools, the mathematical ability, or the research skills that many scientists are trained for, but I can at least attempt to be rigorous. I can at least attempt to have humility, and which is something he brings up in a number of quotes and mentions himself. The allowing oneself to be wrong about something, allowing oneself to know that no matter how relatively truthful a particular conclusion may be, it ain't the whole thing. It can't be. So I think he really gets at what a truly scientific mind or thought process looks like or should look like relative to the approaches that we're seeing quite often in mainstream science, in science that seeks to promote a particular agenda politically.
Most definitely, yeah. I mean, the abuse of science is just rampant these days. I think everyone can kind of acknowledge that, and also maybe to add one point, I think we have talked about this before, but how important it is not to blow, or let's say not to take certain scientific findings and construct a whole like metaphysics out of it, right? I mean, I think that's the big trap that, as you said, like most people would call scientism, but it's almost like today in science, it's so embedded in science that it's actually like you could say that science itself, produces this kind of thing where you make huge proclamations about how the universe works, or like how, even in physics, which, arguably is kind of like the king of the sciences and the role model, and for in science, you jump to conclusions, right? So you make generalizations that you say this is universal, right? So this is true, like has always been true, will ever be true, and is true in the whole universe, for certain laws, but you obviously you don't know, right? I mean, you can't know. So that's the kind of traps that one should really be aware of. And I think humility goes a very long way in that regard. And the world would definitely be a better place if science was very humble in that way. And also with regard to data and all of that. So it's really hard. I mean, there are limit cases, I guess, where you can really say, okay, this is the, almost the absolute truth, at least from our perspective, where you can say, okay, this just, we demonstrated something. But in most cases, it's actually not like that. And if you look at statistics, for example, I mean, it's so obvious, like that you just, change a small parameter and you get a whole completely different result. And in many cases, it's like that. And this is something that, there doesn't exist a meta rule, how to set these parameters, like like in statistics, for example, to get to the truth, right? So you can argue, like, should I, look at this, or like age span, or should I like maybe put cut my data, in the middle, or like at this point, and there's no rule dictating like that's how you should do it to be truthful, right? It's decision basically, and there are so many things like that, and so we should really be skeptical also in a way if scientific papers, they make pompous claims in their abstracts or something, or even like in press releases and things like that. We should really be skeptical, and not to say that, like, go to the other extreme, so that there is no truth and science is like complete bogus or something like that. I mean, that's not helpful either. But really go about it with a as McGilchrist said, with a disciplined mindset of like really trying to figure things out instead of like seeking this closure thing, Harrison, that you mentioned.
Mm-hmm. I was just when I was looking over these chapters and listening to you speak, Luke, it made me think about the Big Bang. So I haven't, like Ilan, I am also not a trained scientist. So I haven't looked into, well, I know that Stephen Meyer in his recent book, the God Hypothesis, Return of the God Hypothesis, has a whole section on the Big Bang and interpreting that as as being a good evidence for like a creator, for God. And I want to read that because I want to see. I looked at this years ago, but I wasn't qualified enough to remember it or to really understand it. I want to see if in all of the evidence and arguments for a Big Bang, if any of that is predicated on the assumption of like constant laws. For instance, gravity. Because I know there's some relation with, they look at gravity and they look at all the like dark matter and the background radiation and stuff. And I know that gravity has to have something to do with it, right? Because the bodies of the universe are attracted by gravity, and so there's got to be some movement going on there. But if the gravitational constant is in any way essential to the Big Bang, then the big assumption there is that that gravity is a universal and eternal constant. And this is one of the things that Whitehead questioned, and that and like you said about laws, we really have no way of knowing how universal these so-called constants are. Now, in our experience, and according to the limits of our experience, what we can observe in the universe, and the movement of cosmic bodies that we can observe, and what we can test on the Earth, the gravitational constant does seem to be fairly constant. But if you look at like Rupert Sheldrake in his book, Science Set Free is one of the titles, and I think its other title, either in the UK or US, was The Science Delusion. I can't remember for sure, but Science Set Free is definitely one of them. And he's got this section on
they wanted to do it more positively for the US public, I think.
Yeah. So he's got this section on the constants in there, and he's got the one on gravity, and it's like, even now, scientists can calculate like the gravitational constant to a very fine degree, but there's always there's always error bars. Like there's always a range of values that they get. It's not like they've gotten to the point where they consistently get exactly the same value every single time. Now, of course, one explanation can be, our tools, our measuring devices just aren't good enough yet to achieve that. I can't remember if he has a response to that or not, like whether that's a valid concern or not. But he brings up the very rational possibility that maybe the constants aren't constant. First of all, they may be like stochastic in nature. They may hover around a particular value, and you can never quite nail it down where it is. It might be probabilistic. But if that's the case, then that opens up the possibility also that Whitehead was pretty adamant about, that we look at the possibility that the laws themselves evolve over time or change over time, and that so the laws, the constants at a very early stage of the universe may have been completely different, and they calibrated in some way, just like organisms calibrate. And so that opens up a whole different perspective on the so-called fine-tuning of the universe. It's not like, okay, these were all the values that we needed, and then either God or just some mathematical physical necessity just determined them to be so, and then flap. They were just set in motion from the beginning of time. That might not be the best way to look at it. Maybe it was this chaotic situation early on, and you have all of these conflicting values that don't quite work towards each other or work with each other. And then who knows? Maybe the calibration was very fast, but I suspect that might have that might have implications for looking at the long-term history of the universe and how things developed over that time. So even with just that, you can't. It would be difficult to say with certainty, we know this is exactly how it must have happened, and therefore this is exactly how it did happen. Because, well, first, we weren't there, and second, we don't know if the conditions under which we construct our model applied in the same way at all times of our vast and long, duration of study, the period of time that we're looking at. So that's kind of one of the big cosmic examples of the possible flaws with getting attached to this model, to any model, and then assuming that our assumptions and observations for the present time must necessarily extend back in time and apply equally well to those initial and subsequent conditions. And so that's a big example, but the same applies with small examples. So the same will apply in any given field or in any given area that you're looking at. You always have to take into account the fact that you might not know, you might not have all of the necessary data to come to as complete an understanding as possible. Well, we just know that. Whenever you're looking at history, and I'm talking about history in the sense of like human history, like the Collingwood sense of human history, there's always going to be things that you just don't know and you can never know. So you can come to a pretty good idea about some things if you have enough evidence, but there's always going to be that room for uncertainty that, I don't know if I can state this with any certainty because there are these unknown unknowns. There are the things that we just don't know that we don't know. And then there are the things that we know we don't know. It's like, okay, well, we don't have data for this. We don't understand what these conditions were like at that time. So how certain can we be with our conclusions about this? So there's always this gray area when looking at history. Now, the thing that I like is when someone comes up with a way, like some very clever individual comes up with a way of kind of taking that into account, or saying, oh, well, we lack that data here, but let's look at this other example, and we see how that data is present here, and we can see how it affected here. So we can come up with a kind of a pretty good guess of how it might apply to this situation where we're lacking that kind of data. And that's the kind of left brain thing that it's left brain, but it's fun and it works, and it's fun to see. It's fun to see when it works, when you can come up with that generalization that seems to apply and seems to actually bring a level of clarity to a situation that was murky beforehand. One of the books that I'm reading right now is I think it's the latest one from Peter Turchin. We've discussed him a couple times on the show. His Ages in Chaos book on American history. And then he wrote War and Peace and War and Secular Cycles and a bunch of other books. But this one is called Ultra Society, and it's about the history. It's kind of a dual history of warfare and the cultural evolution of cooperation. So he's trying to answer the question of how, in the present time, how did huge states that are highly cooperative come about? Like, what was the cultural evolution of that? And he points out that, on some questions, I can't remember the specific question, but it's a point that can apply generally. He points out that, okay, here's this question of how do we explain this thing? So it might have been, it was something related to warfare and how certain things developed. I can't remember exactly what it was. But he says, you look through all of the people, all of the scientists who have tried to answer this question, and you come up with like 200 different answers that they give. And most, it's kind of like the religion question too. It's like, well, most of these answers are not compatible with each other. They can't all be true. And it turns out that a lot of them just aren't true. You can easily falsify them, now that we have a lot of data. So let's look at how we can find something that actually is testable and actually works when looking at all of this data we have from all of these cultures for the last 10,000 years. With the data we have, let's kind of by process of elimination see what we can come up with for the actual things that explain better than all the other things why this actually works. And so that's the kind of it's that aspect of the scientific method that can be very effective, and it's actually it's enjoyable to see it play out and to see the kind of results that people come up with. And like McGilchrist, he can, taking some things out of context or focusing on some certain chapters, you might get the idea that he's like this anti-science kind of guy. But of course, he's at pains to say, well, no, that's not the case. Like the whole book is, the foundation of the book is all of this scientific data on the hemispheres and all of the experiments and all the observations of how this actually works, and how this how this is actually in these certain fields and in these certain areas, this is a better explanation than these other explanations. And so to kind of just summarize a couple points from what I was just saying, I think that in itself, it highlights that contrast between the right and the left hemispheres, how one can be highly flawed, but it's also necessary for it's actually necessary for engaging in the kind of thinking that will support that grander right hemisphere vision, and to kind of correct it and mold it or shape it or reinforce it with things that are actually true. Because it's very easy to look at something and then come up, in that creative process, to come up with this idea and say, oh, well, this must be the answer. This has got to be the thing that explains all of this. And that answer can be wrong, right? It's not like being creative automatically makes one right. It's not like if you have a great idea that pops into your head, even if you're an expert in this field, that still doesn't guarantee that you're going to be right. I mean, there's going to be some reason that you came up with that, and you might be able to track those reasons, like, oh, well, you had this understanding of this data, and that actually is a good explanation when looking at this data, but it turns out it's just wrong because A, B, and C. You didn't have an understanding of all of these other bits of data, or you ignored, and you didn't realize you were ignoring, these relationships among the data that you were actually looking at. So as he says multiple times throughout the book, there are better and worse explanations for things, and there is better and worse art. And when it comes down to the details about why, that's where you'll get a lot of the grayness and the disagreements. But he points out that that when you look at the limit cases, when you look at the extremes, everyone can agree, right? Everyone can agree that a really objectively bad painting is worse than a really, really good one. You might find some people that don't like the really, really
Hopefully.
good one. Right. Yeah. Well, I can't remember the examples he gives, but the examples he gave sounded pretty solid. It's like, oh, well, he was just giving, he gave like absurd examples, like about like interpretations of Shakespeare, right? That's one that I think he came back to a couple times, where he says, well, you can have like some pretty crazy interpretations of Shakespeare that he thinks are just wrong, and people might disagree with him, but you can't take any given Shakespeare play and say objectively, truthfully, this is about like the Marxist struggle of the proletariat against blah blah blah. You can come up with absolutely ridiculous explanations that are just wrong, and that you can with like a very high degree of certainty say this is not a valid interpretation of Shakespeare. So yeah, I'll stop.
Yeah, I just maybe want to add something about what you said about science, which I think is really important, that we shouldn't throw out the baby with the bathwater, so to speak. And I think maybe a good comparison between like what is wrong or what can be wrong with science today and what good science might be is like, if you think about like a lab technician, right, who just put some, I mean, I don't want to insult lab technicians. I don't know a lot about what they do, but that's just
go ahead, insult them
for the sake of argument. Yeah. So basically you just put some probe, into a machine, and then you write down some numbers, let's say. And so, I mean, that's basically how a lot of science so-called works these days, right? For many reasons, you got to churn out papers, you got to, bring in funds and what have you. And it all needs to be like very mechanized and all of that. And so, I mean, and if you, I can really recommend people to read Werner Heisenberg's autobiography. I forgot the title in English. In German, it's called Der Teil und das Ganze, the part and the whole, quite fittingly. And you can like really see how these pioneers, in physics, how they actually worked. And it turns out like a big part was just, Heisenberg and Wolfgang Pauli and all of those guys being on a sailing trips with Niels Bohr, right? Because Niels Bohr had this little sailing yacht or whatever, and they were just going for months, on sailing trips and talked, about all kinds of things, and Heisenberg had his famous, developed his famous Heisenberg uncertainty principle, actually in some kind of like isolated little house in the mountains, where he took some time off because he like wasn't feeling well or whatever, and had like this inspiration, then and there, and it's like, and these guys, they talked forever, and when you read his autobiography, it's like, I mean, they talked about like all kinds of philosophical things and everyday things, and mixed that with like camping trips and like outdoor stuff, and I mean that's kind of like, they did science, right? But it doesn't look like the lab technician science. And of course, they also had access to all the experiments. They had labs and what have you. But that was just one part of it, and the other part was just spending months, chilling and exchanging ideas and being inspired. And it's really fascinating to read that kind of thing. And many, I mean, this was kind of like the golden age of physics, right? And during that time, where like a lot of happened, and it's such a stark contrast to what we're seeing today in many scientific fields, and that's maybe a good way to think about this left brain, right brain divide, and how you might bring those together, and how science actually works, so to say.
Well, that kind of reminds me of a passage in these chapters where McGilchrist says that there are discoveries in physics that he finds quite unfortunate to have been neglected by biologists, that should biologists think on and reflect upon these discoveries in physics, may be all the better for it, and possibly enable them to come to a different understanding of their area of specialty, biology. So there's this recognition that the sciences have been unnecessarily separated one from the other. And while it's understandable that you'd want to focus and get proficient and knowledgeable about your particular area, it could also be, at least according to McGilchrist, quite limiting, because there are insights and ideas and a kind of expansion of understanding that is implied in some sciences that could be and according to him should be assimilated and used to flesh out and grow one's own researches into biology in the example that he gives. So I thought that was interesting, and I thought that who knows, maybe maybe it was those camping trips that those guys took that led in large part to the very fact that, according to McGilchrist, physics is so far ahead in its own realm relative to biology. But then you have guys like Stephen Meyer, for instance, biologist among other things, who does seem to have gone very far ahead and putting aside the mechanistic approach to biology that seems to be so much a part of the common understanding, or the most promoted neo-Darwinistic perspective on biology. So I would say at least a part of it is that you have gatekeepers in various positions in academia and other places that are very vehement that everything is a nail, because in fact they are the hammer that's going to insist that their ideas of what is real and what is true are the correct ones, and that those ideas are the ones that you should believe too, lest you be thought of as crazy or misguided or whatever.
Speaking of biology, Luke, I want to hear your thoughts on chapter 12, the science of life. What did you take away from those?
Basically, that Dawkins was kind of crazy. No, but I think that his main point is basically that he rejects the mechanistic view of the universe in general and biology in particular. So this machine analogy that we're so used to in biology, he basically says that this is completely wrong, or maybe not completely wrong, but at least like extremely narrow in its outlook. And he actually makes a similar point as Collingwood. I think we discussed this maybe in the show about Collingwood, that basically physics, as Ilan said, gave up on the strict machine model of the universe, even after, during Max Planck's time, and even more so after quantum physics and Einstein and all of that. So basically what happened is that physics developed and went beyond like the 19th century materialism dogma, because they had to. I mean, it's not that, I'm not saying that modern physics justifies all kinds of woo-woo, and what ghosts and so quantum physics, therefore ghosts, I mean, it's certainly not that simple. But I mean, it's clear that this primitive understanding of the universe as a machine and every made of little atoms and that bounce around, and so that just the story at least is not as simple as that, and everyone was forced to recognize it. But the biologists, and by the way, also many philosophers, they held very tightly to this machine analogy. Weirdly enough, so that it was almost like a reactionary backlash against the modern physics, and so of course in the 30s, I think the neo-Darwinian synthesis was developed right after like all the quantum discoveries and all that. And it's kind of interesting that the biology just got really stuck in this machine model and treating humans and life in general as machinery. And what's really weird about this too is that as McGilchrist points out, it's so blatantly obvious that human beings are not machines, and life is not like mechanical. I mean, it's just so it stares you in the face, right? I mean, and what the machine analogy proponents did was basically expanding the analogy to the point where you can say like Daniel Dennett and some of these people, yes, the brain and consciousness and everything is just it's just a machine working and stuff, because we could imagine that hyper complex machine that has these and these attributes and is super complex and blah 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 could produce this stuff. But I mean, if you go that far, then it's not a machine, right? I mean, you cannot. It doesn't have anything to do with a car or even with a computer. It's just over. Like the analogy has just run its course, right? And isn't useful anymore. And that's a good point. I think that McGilchrist makes, and not everything of that is new. I mean, he cites lots of people who have criticized this very approach to biology, but I think he brings it together really, really well, and and offers like a whole array of reasons why that just can't be right. I think in general he has a very Whiteheadian view of things, and he cites a lot. Forgot the names, but one book, Process Philosophy of Biology or something like that, basically what Whiteheadian interpretation of biology. And I think he gets a lot of his inspiration from the Whitehead people, and speaks more of processes and flows, and that in biology, like, everything is extremely interconnected, that you cannot even tell apart, the various parts and their functions often, because it's like so interconnected. And of course that applies to the gene as well. I mean, nowadays it's even questionable, even in mainstream science, whether a gene is actually like a thing. I mean, it's not so obvious. You have the DNA, but it's not so easy to define what a gene actually is. And so right there, like the Dawkins thing gets problematic, but it goes even further, that now we know that like gene expression and all of that, it's just extremely complicated, and it's like information that comes from all around, and from all these different systems. And so the machine model doesn't work. And also, like, last point, and that's also not a new point, but I think it's an important one, is about the language we use when talking about these things. I just said, systems, and that's just one example of like how extremely saturated biology is with this kind of mechanistic language. And you always talk about like functions and systems and data input and output and all of that, and as if it's a computer, right, or a machine. And this habit is really strong, and might obscure like what some aspects, or some crucial aspects about what is really going on there. And on the other hand, last point about language, is that all the biologists still can't help but use language from the human realm, right? And even Dawkins and like the diehard like materialists, atheists kind of people who are biologists, they always talk about, this gene wants to do that, and plans to do this, and its purpose is for that, and with that function, it like this system, it intends to blah blah blah. So they always use this kind of language from our human conscious experience, and basically project it onto a machine model, which is the only reason basically why it works, or why it can be convincing. Because if you say like, a selfish gene, it convinces the organism, to, I don't know, lay an egg in another bird's nest or whatever. And I mean, that's kind of like, you can kind of understand, right? You imagine like, oh yes, the gene, I mean, it kind of convinces like, someone, and it's all from the human realm, right? And maybe that's the case, maybe Dawkins is right, but then it's not a machine, right? The gene is a conscious being. So you can't have it both ways, right? But that's what these people try.
Yeah, they try to have it both ways by, like, whenever that's pointed out. I'm sure McGilchrist quotes some and points this out. Whenever that point is brought up, that you're using this like agentic language, imputing all of these motives and propensities to these inanimate things, then they'll say, they'll even write this in the papers themselves. Sometimes, if they're self-aware, it's like, when we use these words, we're not actually using them according, they're just shorthand for the things that we observe that aren't actually, but as you point out, yeah, but if you get rid of them, none of what you're writing makes any sense, right? You realize that.
At least it's like totally unconvincing, right?
Right. So maybe you should take this into account and think about it and say, well, maybe there's a reason in addition to just the fact that, we're humans and we project these things out onto the world. Maybe there's something more to it than that. And of course, that's what, one rejoinder to that will be, oh, well, then you're just going back to this animistic belief that everything has a spirit and, that rocks are conscious and things like that. But it's not the only option on the table. Just read some Whitehead, because for Whitehead, all of these inanimate things, I mean, they are at their very basic essence, they are feeling things, like that they experience and express values and emotions on a very primitive level. So a hydrogen and an oxygen atom, they like when they get together and they feel nice and stable when they combine to make water, and it's a harmonious relationship, but when some heat comes along, it gets the emotions going and they get so worked up that they separate from each other and they become these two gases. Well, I'm not sure if I gave a totally scientific description of what happens there, but it's another process that will separate them. But that's kind of what he's saying. That in itself is too human, projecting a bit too much of human emotion in there. But in essence, like that's essentially what he's saying, that these are rooted in feelings. There's a certain type of feeling that comes. Well, energy is feeling for Whitehead. That when you measure energy, that's the measurement of what he would describe as feeling. The actual experience of energy is feeling. So when you see inanimate things, when you see energetic interactions and chemical reactions, those are the chemical and the physical manifestations of primal feeling in the universe. And then that gets translated up onto, every level of being. You have more complex organisms like mammals and like humans, and that feeling takes a different form. It has to do with different reactions in our bodies that are felt, and sensations. Everything comes down to sensation and feeling and purpose, and that there are purposes that things do, that things are attracted to future states, whether it's conscious or not. So for Whitehead, everything is attracted to a future state, to an attractor, and it's motivated to move towards those various attractors. And depending on different conditions, it may or may not reach that one, or it may or may not reach another one. And so that's what probabilities are. There are probabilities for which attractor will be most attractive to any given organism, or any pair of organisms, or any group of organisms. And so it isn't totally inappropriate to use this kind of language in biology or even in physics, because at the root of things, that's, according to Whitehead, that's actually what's going on. And that there is purpose and feeling even at the, that very basic level of physics, of physical, energy and particles.
Here's a question. If say like a rock in space, just like a rock floating in space, right, is just kind of sitting there, how does it know to move if it gets hit? If it doesn't have some kind of conscious awareness of the laws in which it's supposed to obey?
Well, I actually thought about this deeply. No, not that deeply. But for Whitehead, we talked, or I mentioned earlier about the physical laws, right, and how they develop over time. And this aligns with Sheldrake. I listened to an interview with Sheldrake recently on Whitehead and on the influence of Whitehead on him. And Sheldrake himself said he loves Whitehead, but he can't understand a word that he says. So but whenever he has someone explain Whitehead to him, he's like, oh yeah, totally, yeah, that's awesome. I agree with that. And So there's a lot of similarity, and he hadn't even read, if I remember correctly, he hadn't even read any Whitehead or wasn't familiar with his work when he came up with his morphogenetic fields ideas. And so it was only afterwards that people were pointing out the similarities to him. And so he'd look into it and say, oh, wow, yeah, like we're saying almost the same things in these areas. So there's this for like very brief rundown of morphogenesis, like, and the things that Sheldrake will say is that, like the more you do something, the more it becomes a habit and the harder it will be to break. So he views and I think that Whitehead actually uses the same language. He calls laws the habits of the universe. And Sheldrake says the same thing, that these are habits. And so habits, and for the basic physical elements of the universe, they're like the strongest habits that you can have, to the point where you probably, you can't really do anything else, right? So that's why chemistry is so predictable, is because these different chemical organisms, like the periodic table of elements, they have their character is so strongly formed that they only behave in like this. They only behave in certain ways all the time, as far as we know, right? As far as we're concerned, they've become habits that are so entrenched over billions of years that, an iron atom is going to act like an iron atom and not like a hydrogen atom. And of course, that will have to do with properties, properties of the atom itself. The same thing goes for subatomic particles. So for like a neutron, neutrons all do the same thing, and they always do the same thing all the time. Protons always do the same thing, et cetera, et cetera. And there are variations, right? So if you look at electrons and how they behave, there's going to be these probability clouds, and they may be here, they may be there. So there's some wiggle room, so to speak. Some electronic wiggle room. But so with the rock in space, it's like the rock itself, it's kind of, well, for Whitehead, you can't look at the rock itself, because the rock is kind of just like an arbitrary collection of the minerals, and the atoms that make up the rock. So you have to look at the atoms that are making up the rock. And the atoms that are making up the rock are so used to interacting with each other and combining and bonding with each other, that they will stay relatively stably combined, in the rock form. But they also know what it's like to experience themselves, in the universe with the way that things work. It's like, we. And that vast experience is, while I'm falling through space, I move, I'm attracted towards this thing, and there's nothing I can do to get out of it. It's like, I'm just going with the flow. That's a lot of what I think it is. It's just going with the flow. That's what organisms with like, the limit case of consciousness, which is like almost zero consciousness, or an almost zero awareness experience, is that they just go with the flow of things. Okay, gravity, this is where I'm going. With a bit more consciousness, we can say, no, I don't want to be doing this. I'm going to do something to evade gravity a little bit. So we have these little tricks that we can use. I mean, we can't just totally turn off gravity. We don't have that ability, but we can jump. We can devise instruments to let us fly, or to avoid to utilize gravity, or the things like, or atmosphere, or air pressure, or whatever. We can use certain things to avoid it because we're aware of it. The atoms in the rock are just going with the flow, so they've got their bonds that they've formed. They've got their homies in this rock. And then if something strikes the rock, right, then that's an energy, that's information that they're receiving from this strike. So that now they've got an option. It's like, we were connected, and we were fine being just what we were, but we've just experienced this energetic like event, and now we have to respond to that energetic event, because every interaction, like I can't remember who it was he quotes in the book, every physical interaction is, there's a give and a take. Both are important. So this thing that is striking us gives us energy. Well, what do we do with energy? Well, in all the previous times where we've experienced this energy before, we react by, splitting. And these are the habits that have developed been developed by matter over time. And so they're just going along with the flow. They only know one thing to do when they get struck by a sufficient force, and that's to split. And they only know one thing to do when they're in the depths of space, and that's to float and follow that flow of gravity to the nearest planet where they can cause a mass extinction event.
But that still leaves the question open of consciousness, because how do they develop the habits without some kind of without some level of consciousness there for which the habit to develop into?
Yeah, it's the feeling they like it for some reason. It's like the with the goals, that's the I'll have to think about this, but they've got things that they like, and they like different things from other things. And so something's been influencing them, whether it's that like a tractor in the future, it's like, I want to be like this. And so that causes their likes to be different, their tastes to be a bit different. So, they're different atoms will have different tastes for the types of experiences they like to partake in.
But I guess it just kind of like came back to say that it's not wrong to give like conscious experience, or like to have that as like a connotation of interactions that things have, and the way that we describe how elements interact and stuff. It's not wrong to use conscious language, or language which one attributes to a conscious being, to something that is seemingly unconscious, for the simple fact that there must be some level of consciousness in order for those interactions to take place.
Or awareness.
Yeah.
It implies a certain, so what you're saying there is that, we can now afford to expand our definition of consciousness or self-consciousness. And that's freeing. So there's a certain habit, or as Harrison was saying, or a certain pattern of consciousness that exists in a rock, as opposed to a plant, as opposed to a mammal, as opposed to, an even higher intelligence. So I think that's also what McGilchrist is getting at too. It's that we can afford not to look at everything as a law, but as a pattern that we're used to, that we don't have to strictly adhere to all of the time. We can expand our conception of awareness and consciousness and information by the very question of, does this exist in some other form, or how might it be influenced by some third force or bit of information that seemingly changes the rules. But I did want to get back to something you mentioned a little earlier, Luke. It made me think about the scientists who think of biology mechanistically, primarily, because, and we've talked about this a few times already on the show on the subject of intelligent design. I mean, they haven't been given any better a mechanistic explanation of biology than Michael Behe and others have demonstrated through the bacterial flagellum and its comparison to an outboard motor of a boat, and how all of these components are remarkably similar in function in the way that it mobilizes the cell, if I remember correctly. And so, we know through mathematics that it is impossible for an outboard motor to randomly mutate through all of its constituent parts and assemble itself. There has to be an introduction of information, of seeing how all of these components can work together to make this a viable working part of a boat. But the mechanistic scientists, the materialists, will poo-poo the bacterial, the flagellum, precisely because of its very nature, it suggests that there has to be some bit of information or conceptualization as a whole in order for it to work in the way that it does. So I just thought that was kind of ironic that they, in their habit of looking at everything as a machine, once they're being shown, hey, look at how this machine resembles something that humans have constructed, which can only have been put together by a human consciousness and engineering and tinkering and putting things together. Don't you see how that's analogous? Don't you see how that's a good metaphor for how perhaps we were put together on some level, in some fashion, by some other source of information? So,
yeah, they turn it against them, right? And I think to be like a bit oversimplified, the whole intelligence design literature is basically like a footnote, so to say, to the insight that evolution and the mechanistic model are just incompatible, right? I mean, it just starts right there. I mean, if you think in terms of evolution about the world, that living beings evolve and all of that. I mean, machines don't, period. They just don't. So if you try to combine, like evolution with the mechanistic model, like the neo-Darwinists did, then it's just nonsense, I mean, on the face of it, it just can't work. And in the intelligence design literature, they basically showed that, in great detail why that is exactly. So that, I mean, things aren't assembled, randomly. It's just, it's all nonsense. But the issue maybe I have a little bit with the intelligence design argument. I think, Harrison, you went a little bit into that or hinted at that when you talked about Stephen Meyer, is actually that in some ways they seem to be really married to the mechanistic model as well, right? Mm-hmm. So I think, I mean, maybe I'm a bit unfair because I also haven't read everything, right? And I don't want to take anything away from their great accomplishment in just showing in minute detail that neo-Darwinism just can't work. But we shouldn't go back to the kind of, pre-Darwin or like, let's say, like mechanistic model of the universe that was there around even long before Darwin, right? Just with the creator God, right? I mean, that's kind of like the modern idea when the church was still, had still something to say. That was kind of the model. And since Descartes basically came along, this kind of dualistic model that we have this mechanistic world out there, but then we have God, who like created life and these machines basically, and put the soul in there, in some sense. So that's kind of like this primitive model that I think won't get us very far. It feels almost like, like kind of a step back to say, okay, we have this machine universe, with a big bang, and everything is like just mechanical, except that God created it and God created life in it, so to say. I mean, I get the argument, but I wonder sometimes whether that will get us any further. And this sort of Whiteheadian approach seems to be a bit more fruitful, even though I don't think it's the whole story either. But we want to find out what really goes on, right? And it could be all kinds of things. And if we have our like presuppositions like fixed and just think about the world in certain ways, then we kind of get stuck. And I think McGilchrist lays this out quite beautifully when he talks about that everything is more like of a flow and interconnected, and the right hemisphere actually sees it doesn't see like a duality between my consciousness and the external world. It's one, right? It's just one, and it's interlinked and interconnected. And when you talked about the rock doing its shenanigans in outer space and getting hit and whatnot, maybe that's another way of looking at it. That we kind of imagine this rock as having like a consciousness that is kind of separated from everything, and the rock looks around in space, and it's like this rock with this conscious rock and the world out there, right? But maybe that's just, and that's why it sounds so absurd, right? When you say like, oh, but rocks are not conscious, right? But maybe it's just because we are so used to think in certain ways, this kind of dualistic worldview with the mechanical universe out there, and the God-given soul in there, and the God-created life, and it's all neat and tidy and left hemisphere-ish. But maybe it's just not like that. And for example, with the intelligence design thing, I mean, to be fair, most I don't think make that argument, but many seem to think, that basically God did it, right? So God like programmed the DNA, like the computer programmer. But there are like other options on the table, as you said before. I mean, there could be like teleology involved. I mean, maybe like the information assembles because all kinds of different things cooperate towards like a goal that they're attracted by, like McGilchrist says, and it's also like in line with Whitehead. So there are many ways to think about these things and how that all might fit together. And I think it's really good to break certain habits of thought from time to time. And McGilchrist, so far, I'm really enjoying. I've still not finished the whole thing, but I'm really enjoying it, because I think he's really brilliant at this, to kind of make you think about stuff in new ways.
Mm-hmm. I just wanted to add one thing on there. It's the impression I get from the intelligent design authors too. Now I'm guessing there are probably a couple of them that don't necessarily think this way, but by the arguments that they make and the limits that they place on themselves on what they write, that is the impression that comes across. And I think a lot of them are operating in that worldview. And what it essentially comes down to is that they think that life is like, that organisms are like extremely complex, like Lego creations, right? They're put together. We've got all these little Lego bits, and they're put together in these highly intelligent ways. And that implies that that a creator must have put the original Lego bits together, right? And whenever there's a new Lego piece that is created, that creator molds the new Lego piece and then puts it into a new Lego creation. And that's the world that, according to the intelligent design people, as far as I can tell, it's at least the implicit world, is that we're these vastly complex Lego creations, and which is essentially mechanical. And so they don't, and part of that is just by virtue of their operating within the standard scientific framework. And part of that is that they want to convince the mainstream academic, scientific community, look, we follow all of your rules. Mm-hmm. We operate with all the same presuppositions. We won't even say that God did it. We're just saying that intelligence was involved. And when they do venture out from those strictures, then it does tend to be that, most of them are Christian and believe in a like a traditional creator God, but when they're doing their science, they're open to say that, oh well, we can't argue that, it's not scientific to say that. It could be something else. It could be aliens, and so there are other explanations. But I think that those other explanations need to be taken into account. Those other possible explanations, and on top of that, we need to just tear apart the whole mechanical universe at the same time. But that's a different project, right? And so,
you're right.
Yeah.
I mean, it's good that you kind of come to the defense of, because I mean, I think they're really brilliant in many ways. What they're doing, the ID community, and as you said, I mean, they have a specific purpose with their project, and it fits perfectly, to what they're trying to do.
Mm-hmm. But yeah, that was my last thought. Anyone else? Final thoughts? All right, let's call it a night, guys. Yeah. All right, Luke, did you want to take us out, or should someone else?
Yeah, right. And you hosted it, right? So, thanks to my wonderful guests. So thanks everyone for listening, and I hope you enjoy the show. And check out the Harrison's and my Substack in the links below if you haven't. And we hope to see you next time here on MindMatters with a fascinating topic that we're already working on.